Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh.
Bismillahirrahmanirrahim. Tes satu,
Today,
dua, tiga.
our group will presenting to you our group project, which is Rules of Inferences. Next, this is our group members. First, we have ZARITH ASYRAF. Second, we have HAZIQ NAQIB. Third, we have DANISH HAIKAL. And lastly, me and myself is AMEEN AKEEF. Next, this is our project overview. This project focuses on using the rules of inferences in question 1, constructing an inference engine that translates English statement into propositional logic. The 8 rules, which is modus ponens, modus tollens, disjunctive syllogism, hypothetical syllogism, conjunction, simplification, addition, and resolution, provide a logical framework for making judgment based on presumption. The program aims to facilitate study and encourage independent research, strengthening students' understanding of discrete structures. Next, this is the problem statement. First, the understanding how the inferences work. The students are unable to determine the difference between the rules and lack a clear understanding of how each rule of inference works. Second, memorizing issue. The eight principles of inference are challenging for most students to memorize since they are commonly misinterpreted when implemented. Next, for the third problem statement, is mistake of translating the hypothesis. Students usually make a mistake when translating the hypothesis from propositional logic to English. And lastly, it is a design and develop an automated inference engine using rules of inferences. The system is capable of converting English statements into propositional logic and apply the specific inference rules, which is modus ponens, modus tollens, disjunctive syllogism, hypothetical syllogism, conjunction, simplification, addition, and resolution.
So continue to my part, which is I'm gonna explain about the coding of the system. So we have used Java to develop this logic and inference system. So in this case, in the coding, we have used HashMap, which is it works as a dictionary for the rules to install the information. So within it will be called from the HashMap. So for this part is the expected queue is like a hint for user in case they don't know what to insert under they choose the rules on top of it. So in this case we have used switch case, and it is part of the coding. It will take the correct value of the user choose the conclusion, and then it will give the result of the conclusion based on the user conclusion that user have been chosen. And then for this part of coding is a validate inference. So after the user choose the conclusion, so this part will determine which is it will say that the conclusion is valid or not valid. So this part of coding will be like the brain of the system. It will determine whether the result of the rule of inference is false or not false. So for this part is it will work as a expected answer, which is the correct answer if the user have choose the wrong answer. So if the user choose modern tolerance and they select navigation P, and it will return the case 1, which is Q, which the correct answer for modern tolerance. And also we have used a switch case same as the method before. This is the last part of the coding. So in this part is a bit tricky. So you will get the rules that user selected and their conclusion, and then it will validate the input, which is it will check whether is it empty or not. So it will convert the rules that user have been chosen by using the hash map that I have shown in the first part, and then it will call validation method to check if the answer is correct. So after is it correct or fail or not valid, it will cause an appropriate feedback to show that it is success or test an error message. So this is the coordinator for every class that it will do everything together from the first part into the last part to show the result. So this is what happen after the user click the evaluate logic. Okay, so this is how the user will work. So in this here we have the section where the user can select inference rules, which is we have all the inference rule 1 to 8, and then we can put the conclusion and user can choose by clicking the conclusion uh, above below on it. So we show the how it works. So I will choose hypothetical syllogism. I will choose P to R, and then I click evaluate logic. So it will test that the rules on inference is valid. So what happen if I choose the wrong conclusion? So in this case, I choose conjunction, and I choose the wrong conclusion, which is I put the wrong one, and then it will test the wrong conclusion that the rule in inference is not valid. So what happen if uh, the user want to check the correct one after they have they failed the conclusion they have choose before? So I will just click clear, or you can just click to new session, and then I choose conjunction P Q, and then click the evaluate logic, and it tests the rules of inference is correct, which is valid.
Moving on to the output interface, this is an example demonstrating a valid application of modern components. After selecting modern components and building the conclusion, the system displays a valid inference message. It clearly states the rule applied and your conclusion. More importantly, it breaks down the logical reasoning, showing premise 1, premise 2, and conclusion in both English and propositional logic. When correct, you will see a result. Your logical reasoning is correct. Well done, message. Here's an example of the modern modus ponens output when the interface is not valid. Similar to the valid output, it shows the rule applied and your conclusion. However, the result will indicate that your logical reasoning is incorrect and encourage you to keep practicing. This immediate feedback is crucial for learning. Okay, next we have the output for disjunctive syllogism when the interface is valid. The interface is consistent, showing valid inference and clearly detailing the logical reasoning with premise 1, premise 2, and the derived conclusion. Again, a well done message signifies a correct application of the rule. Okay, now and here's how the system responds when the disjunctive syllogism is applied incorrectly. It shows an invalid inference message and provides a hint, which is use the button to build the correct conclusions. So the result also clearly states your logical reasoning needs improvement. Keep practicing. So it shows that this constructive feedback guides the user towards understanding for their mistake.
So, as we know, for the resolution rule, the conclusion for it is Q, or R. So in this role, we know that it will emulate the P, and the result will show the Q or R. So this system it shows that the rule is valid, which is it tests the premise 1, premise 2, and the conclusion. So this is the output when it shows that the rule of resolution is not valid. So as you can see, the answer that will be that is given is a Q or P. And we know that the correct answer is Q or R. So it will show that the rule is not valid. And then it also tells the expected answer, which is a clue for user to enter a correct one.
So for the next one, we use the rule hypothetical syllogism. So the rules is about the connecting statement logically. So for the logical reasoning, if P implies Q and Q implies R, then logically P implies R must also be true. So then the system will check the reasoning step by step. Then it will the final conclusion that P implies R a valid inference. So for the next one, we use the same rule, which is the hypothetical syllogism. As we know that this hypothetical syllogism it's P implies Q and Q implies R, then the valid is P plus R. So for this one, the conclusion given was P plus Q, which is incorrect because it is simply repeats one of the premises without applying the logical chain. So for the correct application, you should connect the two conditional statements through the shared term Q, resulting in the quotient P implies R. Therefore, the reasoning is invalid, and the expected valid conclusion is P implies R, just like the before this. So for our conclusion, it is our group project on propositional logic rule inference demonstrate a systematic and effective method for reasoning and drawing conclusion from given premises. The developed system efficiently process complex logical statement using various logical support and simple input, and it delivers clear and accurate conclusion. For overall, the project highlight the importance of logical reasoning across multiple fields, contributing to improve problem solving skills and more informed decision making.